All right, welcome back. Today we're going to talk about section 7.4, finding the determinant of a square matrix. So we're going to focus on 2x2s and 3x3s with that today. We'll start out with the 2x2. When you take the determinant of a square matrix, really all we're doing is cross multiplying. So we start in the upper left hand corner, we multiply these two numbers and subtract the product of these two. So basically you're just making an X, and we'll show that on the next slide actually with numbers. This little designation here, A11, just means the number in the first row, first column. A22, second row, second column. So that's what that little designation means, but we'll show you with numbers, it'll be easier. So to find the determinant of this matrix, we will do 14 times 105 minus 17 times 2. So pretty straightforward calculation there. The determinant of this matrix is 1436. Similarly, same deal here. Cross multiply 4 times 43 minus 21 times negative 46. Watch your signs right there because we're subtracting a negative, so we're really adding then. And the determinant here is 1138. And one more time, negative 10 times 8 is negative 80. Negative 11 times negative 13 is a positive 143, but again, we're subtracting, so make sure you watch your signs carefully. Negative 223. You can do the determinant of a 2x2 on your calculator, but typically we ask you to do those by hand, and it will state that on the quiz or test. It'll say by hand, and again, it's pretty quick calculation, cross multiplying. 3x3, you can do it both ways. It's on the calculator, and then we do something called minors and cofactors. I'm going to show you both here. So if they ask you to use a calculator, you just enter matrix A into your calculator, and then under the calc option, you take determinant, DET, and take the determinant of A, and that will give you 182. That's pretty straightforward. I'm going to go through the by hand process again because you're going to have to know both and how to do that. All right, so minors and cofactors, we only use these for matrices that are larger than 2x2, and for our purposes, we'll only do 3x3s here. We're not going to get into 4x4 and 5x5. You can do those, but that's beyond what we need to do. And unfortunately, you have to find both. We need to find the minors in order to get the cofactors, and that's how we find the determinant. And I'm going to walk you through that process right now on these next couple slides. All right, so as you can see here, this is a 3x3 matrix here with matrix A. Now, all the numbers here are filled in. That's great, but I'm going to explain to you how we got that. So we'll start with the minors. And so you see this is minor 11, and what that means is we are going to take the first row and first column. Basically, we're going to ignore or cancel them out. Now, I made these transparent, but you can use your fingers, you can use a pencil, you can use whatever you want. We just basically cover the first row, first column, and you notice we have 4 numbers left. And now we treat this like we would a 2x2 determinant. So 4 times 2 is 8 minus 6 times 5. So 8 minus 30, negative 22. To get minor 12, we do the same thing. Row 1, now we go to column 2. You can see we got 4 numbers left. So 4 minus 15 is negative 11. Minor 13, first row, third column. So again, I got 4 numbers left here. So 12 minus 12 is 0. So we're 1/3 of the way home. M21, that means second row, first column. Let me just get this over here and get this one done. There we go. So second row, first column. And you can see that again we have 4 numbers left. So 4 minus 18 is negative 14. M22 means second row and second column. So we got the 4 corners. 2 minus 9 is negative 7. Minor 23, second row, third column. So 6 minus 6 is 0. Excuse me, got the wrong one there. And now we got 3 left to go, and that's our third row. So we'll move this down to the third row. First column. I try to do these in order. You don't have to, but I think it gets to be too confusing if you don't. So row 3, column 1. So I got 10 minus 12 for negative 2. Row 3, second column. 5 minus 6 is negative 1. And third row, third column. 4 minus 4 is 0. So that's our minors, and that's really the time-consuming process of this. To get your cofactors, notice I have this chart right here. Starts with positive plus, minus plus, kind of like a checkerboard. Every other one switches. And what you do is you apply this chart to these minors. So the ones that have a plus here, that means the signs stay the same. Multiply them by positive 1. So negative 22 times positive 1 stays negative 22. Negative 7 right here in the middle times positive 1 is negative 7. 0 times positive 1, 0. And so you can see that the numbers in the four corners in the middle, the cofactors, are the same as minors. So here's my four corners and the one in the middle. And you can see that they stayed the same. Now, the remaining numbers, we multiply by negative 1. So that's the one in the middle here, the 2 outside, and this middle. And you'll notice that if we multiply this by negative 1, we get 11. Negative 14 times negative 1 is 14. 0 times negative 1 is still 0. And negative 1 times 1 is positive 1. So now we have our cofactors, and that helps us to find the determinant of our matrix, which is what we're going to do here on the next slide here. So what it says here is find the determinant using the third row and second column. And I'm going to show you that on the next page. And what that means is we are going to take the, for example, third row, we're going to take these cofactors times the third row numbers in the matrix. And second column means we're going to take these cofactors times the second column in the matrix. So let me show you that quick. So from the determinants from the previous slide, we had our cofactors, and we took them in the third row. So I'm going to go back for a second here. So we have negative 2, 1, and 0, and we are going to multiply them by 3, 6, and 2. And that's what you see here. So 3, 6, and 2 are the numbers in the matrix times the third row cofactors. We add them up, and our determinant is 0. When we do the second column, the same result happens. So if you notice our cofactors here for second column, negative 11, negative 7, and 1. We multiply those by 2, 4, and 6. So 2 times 11, 4 times negative 7, 6 times 1. That's what you see right here. And we also get 0. The reason they ask you to do this twice, no matter what row or column you pick for your cofactors, when you multiply by the number in the matrix, you should get the same number. And that's what happened here. We got 0 both times, so we can confidently state that the determinant is 0. All right, one more example, another 3 by 3 here. I'm going to go a little quicker this time. So again, when you did the minors here, first row, first column, like so. So 8 minus negative 30 is 38. 12 minus 20, negative 8. Negative 18 minus 8, negative 26. Then we went second row. All right, negative 4. And then we did minus 0, so that's negative 4. 4 minus 0 is 4. And negative 6 minus negative 4, that'll give me negative 2. All right, then we go down to our third row. Negative 5 minus 0 is negative 5. 5 minus 0 is 5. And 2 minus negative 3, so 2 plus 3 is 5. So there's my minors. Use the chart here to get my cofactors so you can see them right there. Again, we're going to find the determinant, so we are going to use our cofactors, these numbers right here. And for this particular example, first row, so 38, 8, and negative 26 times the first row in the matrix. So 1 times 38, negative 1 times 8, 0 times negative 26. Our determinant's 30. Then we're going to do our third column. So we take our third column cofactors and multiply them by 0, 5, and 4, because that's our third column in the matrix. So 0 times negative 26, 5 times 2, 4 times 5. And again, you can see we got 30 both times. So our determinant of this 3 by 3 matrix is 30. So that's minors and cofactors. A little bit of a process there, but not too bad. Typically on a quiz or test, we won't ask you to do more than one of them just because of the time factor. All right, that's your notes for 7.4, so you should be all set for that homework. Thanks a lot.